Hello, welcome back into my channel. In this video, I'm going to explain how we find the solution exercise 8C of Mathematics Analysis and Approaches Standard Level 2. Number 1, state the transformation which maps y equals sin x onto y equals sin x minus 1. We have to start with the graph of sin x. This is the graph sin x. X-axis in integer. If x-axis in pi, this is actually 1 pi. Okay. After that, this is 2 pi, this one. Okay. 3 pi, 4 pi, and 5 pi here. The intercept. Right. So how about graph y equals sin x minus 1? This. Okay. The first graph is the main graph, sin x, and the second graph is y equals sin x minus 1. Look that this graph, sin x, vertically translations to downwards, okay, by 1 unit. Okay, look this. It moves 1 unit to downwards. All coordinates point on the main graph move as far as 1 unit downward. It means this has vertically translation to downward by 1 unit. Okay, so if you would like to graphing y equals sin x minus for example minus 4, it means it has to move as far as 4 unit to downward. But this one, only 1 unit. So we could say that graph y equals sin x translated, okay, translated vertically to downwards by 1 unit. Okay, I think clear. Next for 1b, this one, y equals sine x minus pi over 4. This graph still based on the main graph y equals sine x. So if you would like to graphing this graph, yeah, supposed to be based on the main graph y equals sine x. But look, this this translation negative pi over 4, yeah, negative, it means the translation horizontally. Okay, so the graph y equals sine x translated horizontally. to the right. Yeah, as far as 4, as far as pi over 4. Okay, next, 1c. 1c, y equals 2 sine x. Right, so if you would like to graphing y equals 2 sine x, firstly, based on this function y equals sine x, okay, this graph, and after that, if integer in front of sine x, it means the maximum number becomes from 1 becomes 2 based on this number, this integer, and the minimum number based on this minimum number becomes negative 2. From negative 1 become negative 2. All maximum and minimum number based on uh, this rule. Okay, so what happens if y equals 4 sine x? It means the maximum being 4 and the minimum becomes negative 4. Okay, think clear? So we could say that the graph y equals sine x stretch vertically by scale factor. Scale by scale factor 2. Okay. D y equals sine for x. Yeah. So different just now. We have created graph y equals 2 sine x, but now we are going to create y equals sine for x. If sine for x, look that the graph, this is the main graph, y equals sine x. Meanwhile, the second graph is the graph of y equals sine for x. Look that for one period from this origin until this one, pi. Okay. If y equals, the main function y equals sine x has one wave, okay, uh, one wave at the upwards and downwards, while for y equals sine x, there are four, okay, four waves on upwards and four waves on downwards. Yeah. So about if eight, it means from origin to pi, there are 8 waves on upwards and 8 wave on downwards. So about if 6 here, sine 6x. If sine 6x, it means on one from origin to pi, there are 6 waves on upwards and 6 waves on downwards. All right. I think this is clear. So how about the translation? The translation, we could say that the graph y equals sine x. Yeah, stretch. Stretch horizontally. Okay. By scale factor. Yeah, 1/4. Yeah. Okay. Next. 1e. Okay. 1e. Okay. 1e. Y equals sine x over 4. Just now, we created a graph sine equals 4x. Y equals sine 4x. But now we are going to sketch graph y equals sine x over 4. Okay. Look that uh, the maximum point and the minimum point. Maximum point from 1 being 1 over 4, and the minimum point from -1 being negative a quarter. So all of the maximum points and minimum points of the second graph being like that. This is the second graph, while this one is the main graph. Yeah. Okay, so you may create the graph if sine x over 5, it means the maximum point becomes 1/5 and the minimum point becomes -1/5. So about if sine 2/5 x, it means implicated to the maximum point becomes 2/5 and the minimum point becomes -2/5. How about the intersection? Still same here. Yeah, on pi, 2 pi, 3 pi, 4 pi, 5 pi, and so on. Okay. Next for 1f. 1f, the function is y equals sine x minus pi third plus 2. So there are two translations. Firstly, 2 pi third. Okay. So pi translation pi third, of course, to the right. Yeah. And after that, 2 units, 2 upwards. Yeah. So this maximum point, firstly, translated to the right, okay, as far as pi over 3, for pi over 3, it means if this pi, okay, pi over 3 around here, okay, pi over 3, okay, around here. So it should move pi over 3, okay, and after that, 2, yeah, 2 units, 2 upwards because of this one, 2 units. So after pi over 3 to the right and 2 units, 2 upwards. So the translations of this point becomes this one. Okay. this coordinate point as well translated becomes this coordinate point. This coordinate point as well translated being this coordinate point and so on. So we could say that graph y equals sine x, okay, translated. Okay, there are two translation. One, as far as pi third to the right, it means this is horizontal translation. Okay, horizontal translation. And secondly, by 2 units to upwards. Sorry, not by 2 units, I mean. Okay, by 2 units to upwards. Okay, to upwards, it means vertically translation. Okay. Okay, number one already. Let's move to number two. State the transformation which maps y equals cosine x onto y equals half cosine x. Firstly, we have to start from the main function. This is the graph of y equals cosine x. So, okay. Yeah. And next, we are going to look the graph of y equals half cosine x. Okay. These are two graphs. The main graph is one, y equals cosine x, and the second graph is graph of y equals half cosine x. Look that the maximum point from 1 becomes half, but the intercept point still same on pi, 2 pi, 3 pi, 4 pi, so on. Okay. So the maximum point from 1 being half, from the minimum point from -1 becomes half. Okay. So it means this graph, okay, from cosine x becomes half cosine x. This graph y equals cosine x stretch, okay, stretch vertically. Yeah, by scale factor. Here, by scale factor, half, okay, yeah, becomes this graph, y equals half cosine x. Yeah, this is 2a. Okay, now to b. Yeah. Okay, to b, look this. I have created, this is the main graph y equals cosine x, while this one is y equals minus cosine x. That if you look this graph, actually y equals negative cosine x is the reflection of y equals cosine x. So graph y equals minus cosine x is reflection, yeah, reflection by y equals cosine x. Yeah, on x-axis. Yeah, on x-axis. So it means x-axis is the reflector of cosine x. And the reflection becomes y equals negative cosine x. Now this one, number 2c. Okay, 2c. I have created both graph y equals cosine x and y equals cosine x plus pi over 6 minus 2. Yeah. There are two types of reflection. Okay, two types of transformation. I mean, firstly, this translation. Okay, uh, vertically translation. Vertically translation. Okay, by pi over 6 2 downwards. Yeah, 2 downwards. Secondly, horizontally translation. Horizontally translation as far as 2. Okay, as far as 2 to the right. Yeah. Okay, so let's move to number 3. State the period of y equals sine 5x. Okay. This is the graph of y equals sine 5x. Okay. And look at the period, okay, based on this number. As you know that the period or the symbol period b, b equals 2 pi for 5 or 2/5 pi. Okay, so number 3. Okay, number 3. Sine 0.6x. Okay, this one. This is the graph. Okay, so the period 2 over 0.6 or 2 over 6 over 10. So it becomes 2 times 10 over 6. Okay, 1, 3. Okay, so the period becomes 10 third. Yeah. pi here. And afterwards, one, y equals sine pi x. So it means period. Okay, the period. Yeah, becomes 2 pi over pi equals 2. Okay, that's the period from origin to this is one period. Next number 2D. Y equals cosine 3x. Okay, so the period for B 2 pi over 3 or 2 over 3 pi. And next, 3e. Okay, y equals cosine x over 3. So the period equals 2 pi over 1/3. It's going to be 2 times 3 over 1. And the period becomes 6 pi. Okay. Next. This one. This is the graph of y equals cosine by x over 50. So the period 2 pi over pi over 50. Okay. So 2 pi times 50 over pi cancel. And the period equals 100. So from this origin until 100, that is one period. Number 4, find B or find period given that the function y sine bx, which B greater than 0 has period. Okay, we're going to find the period. If B, yeah, if B equals 5 pi, it means 2 pi, okay, a 2 pi over B equals 5 pi. So B equals 2 pi over 5 pi equals 2/5. Okay. B. Okay. 2 pi over B equals 2 pi third. So it becomes B equals 3 over 2 pi times 2 pi divided equals 3. C, B equals 2 pi over 12 pi. So it's going to be 1/6 simplifications of 2 over 12. D if 2 pi over b equals 4. So it means b equals 2 pi over 4 or half pi. E if 2 pi over b equals 100. So b equals 2 pi over 100 or 150 pi. 1 over 50 pi. Next. Number 5. State the maximum and minimum value of a y equals 4 cosine to x. A maximum 4 times 1 because cosine the maximum of cosine equals 1. So 4 times 1 is 4, while the minimum 4 times -1 because in cosine x, the minimum value is -1. So y equals 4 cosine to x, the maximum equals 4 and the minimum value equals -4. 5b, y equals 3 cosine x plus 5. So the maximum value is 3 times 1 plus 5. Meanwhile, the minimum value is 3 times -1 plus 5. This is 8, while this one 2. Okay, 5c. Y equals -2 cosine x minus 3 minus 4. Okay, we have to check first which one maximum, which one minimum. So -2 times 1 minus 4 equals -2 minus 4, -6. -2 times -1 minus 4 equals 2 minus 4, -2. Oh, it means, okay, the minimum, this one, maximum, -2. Number 6, for the function y equals 4 sine 3x plus 2, state the amplitude period range. Okay. So number 6a, the amplitude, of course, 1. Okay. Then period. Okay. Okay, the period equals 2 pi over 3, okay, or 2/3 pi. Okay. See the range maximum minimum we have to find first. So the maximum 4 times 1 plus 2, 6, and minimum 4 times -1 plus 2, -2. So the range uh, y, which are y greater than or equal -2, less than or equals 2. Okay. 7. The general cosine function is y equals a cosine b x minus c plus d. State the geometrical significance of a, b, c, and d. Okay. So amplitude is a, yeah. So a, of course, amplitudes. Okay. Absolute like this because amplitude values cannot negative. Okay. Then B for periods. Okay. Uh, so 2 pi over a period. And then C. C meaning this is the translation. Okay. Horizontal translation. And D for vertical translation. Okay. Now, 8. Sketch the graph of the following for x in interval greater than or equal 0, less than or equal 4 pi. Okay. A sine x minus 2. Okay. Look at this. I have created this the main function sine x, yeah, because for number 8, all function in sine x and becomes sine 3x, sine 4x, sine x over 2, and so on. But firstly, I have created this main function. If in integer, if x in integer, this the intersection here 3.14. But if in pi, the intersection pi, okay, 2 pi, okay, 3 pi, and 4 pi. Okay, just until here. Okay, yeah. So just until here. Okay, look, if sine x minus 2, it means if we would like to graphing y equals sine x minus 2 based on this main function y equals sine x, yeah. So graph y equals sine x into y equals sine x minus 2, we have to translating, okay? What kind of translation? Okay. Vertically translation. Vertically translation as far as this number, as far as 2. Now the directions upwards or downwards. Of course, downward. Okay. If downwards, it means this origin, the square point, should move 2 units, 2 downwards, 1, 2 move here. And this maximum as well should move. 1, 2 becomes here. This intercept should move here. This minimum should move here. Okay. As well, this 2 pi should move here. Okay. Right. And this maximum should be moved here. And intercept move here. Okay. And here should be moved here. Okay. And next, let's look the graph I have created. Okay, that one. Yeah, ready move becomes this one. So this is uh, the red one is the main function, the main graph, while uh, the blue one is the second graph. But remember that the interval just until here. Okay, here. So yeah, around here. It's supposed to be we have to clean around here. I'm going to supposed to be just until here. Okay. And as well here. Okay. Okay. So pi here, the first intersection, pi, 2 pi, 3 pi, and 4 pi here as well. This one. Okay. Pi. This is 2 pi, 3 pi, and 4 pi here. Okay. Okay. Next. Y equal sine x plus 3. Okay. Again, I'm going to start with the main function, the main graph, y equals sine x. So on. Okay, the condition like this because if sine x plus 3, it means this graph, sine x, will be translated 3 units in the direction where to upwards. Okay, so it's going to be 1, 2, 3. It will be moved here as well. This one will move here. Okay, all the coordinates point. I don't forget this is pi, 2 pi, 3 pi, 4 pi. Yeah, it's something here. This is no. Okay. Yeah. Now let's look the complete graph. This one. Okay. Okay, I'm going to here from this one. Okay. I'm going to clean this one first. Okay. Okay. Right. So look that all coordinates point in this graph, the main graph, y equals sine x, translated vertically, okay, to upwards, okay, as far as 3 units, 1, 2, 3. And Yeah, the second graph becomes like this. Don't forget pi here, 2 pi here, 3 pi, and 4 pi as well at the second graph. Okay. Now, y equals sine x minus 0.5. Again, I'm going to start with the main graph. Y equals sine x. This is the main graph. Y equals sine x. Okay, pi, 2 pi, 3 pi, and 4 pi. How we create y equals sine x minus 0.5 from the main graph based on this number. So main graph should be translated based on this number 0.5. So negative, don't forget, it means the direction to downwards. So the translation is vertically translation to downwards as far as 0.5. So this main this origin moves as far as 0.5 to downwards, as well this maximum move here, this intersection as well move here, okay, and this minimum point should be moved here, this intersection move here, and if we look the graph like this, okay, the blue graph is the graph of y equals sine x minus 0.5, and the red graph is the graph of y equals sine x. Don't forget this until here. I'm going to make it clear, okay? 0.5 is around here as well. Yeah, because the interval from 0 to 4 pi, okay? Yeah, don't forget that the intersection is 1 pi, 2 pi, 3 pi, and 4 pi here. Okay. So meanwhile, this is 0 origin. Yeah. So don't forget if y equals sine x, and if you would like to to draw or to graphing y equals sine x minus 0.5, it should be uh, translation. Okay, what kind of translation? Vertically translation. Number 8, sketch the graph of the following for x between 0 and 4 pi. Firstly, we would like to sketch this graph y equals sine x minus 2. Sine x minus 2, it means, minus 2, it means the translation happening on y-axis, okay, vertically, and minus, it means to downwards, the direction. So if you want to sketch the graph of sine x minus 2 based on the main graph, this the main graph y equals sine x. Okay, sorry. Y equals sine x. Okay. This is pi, 2 pi, 3 pi, and 4 pi. 0 here. Okay, recall that the interval between 0 and 4 pi. Okay. Right. Uh, if translations happening vertically downwards, it means all coordinate point on this graph, y equals sin x, should moving as far as 2 units to downwards. Origins should moving here to 0 point -2, and this maximum point as well uh, going to moving here. Okay, then the intersection pi pi comma 0 should moving here. Okay, and then the minimum point as well. Uh, oh, sorry, pi should moving here. Okay, and this is the minimum point. Okay, and the principal axis uh, going to move here. Okay, so this is the principal axis. Okay, until here. Okay, and after that, just connecting all coordinate point. Okay, I have to wait. Okay, I'm going to show you if we're connecting the coordinate point, it's going to be like this, the graph. Okay, the blue one. Okay, look, that this graph move at this point, coordinate point move here. Okay, this 0, theta, 2 pi, 2 pi, sorry, 3 pi, and 4 pi here. Okay. Okay, 0. Okay. Okay. My application provide this graph, especially on x-axis. On x-axis, the scale in integers. So that's why not on pi, but in integers. Right. So this the graph of y equals sine x minus 2. Okay. And I'm going to show you the graph. This one. Okay. This is the graph of y equals sine x minus 2. Okay. Right. So this is 0 point -2. And as well, this is the translations from this coordinate point. Yeah. Okay. Right. So probably some of you ask me, sir, how about this coordinate point? How much? Yeah. Just this coordinate point just move from uh, the original, the main graph y equals sine x just now I have shown you, okay, uh, how to sketch this graph y equals sine x minus 2. Later on, number 8D, I'm going to show you how you find the maximum point and as well the minimum point, coordinate point. Okay, so we could say that this graph y equals sine x, translated vertically to downwards by 2 units. Okay, next. Okay, y equals sine x plus 3. It means if sine x plus 3 all coordinate point are translated. Okay, I'm going to make clear first this graph. Okay, again, all coordinate point translating as far as 3 units. Okay, as far as 3 units to upwards. Yeah, so vertically to upwards. Okay, so it means this origin, so moving 1, 2, 3 comes here, 0.3, and this coordinate point as well, moving here, okay, and in a set point, yeah, pi, so moving here, okay, and this minimum point, okay, so moving here, and this is 2 pi as well, so moving around here, and don't forget the principal axis should be here, move, okay, okay, and after that we connecting, okay, connecting the coordinate point, okay, and if we connecting, will be like this, the blue one. If I'm going to make clear this graph, okay, so we could say that a graph, wait, that graph y equals sine x translated vertically to upwards by 3 units. Okay, and the graph is fun. is the graph. Okay, I'm going to make clear this. Okay, okay, yeah. This is the graph of y equal sine x plus 3. Okay, there's an intercept point with x-axis because all coordinate point moving to upwards by 3 units. Now this one, y equals sine x minus 0.5. Okay, so this how we sketch the graph based on this main graph y equals sine x. Based on this information that all coordinate point should moving two downwards. So it will be translating to two downwards. So because it is vertically translation, so this move to this coordinate point, origin 0. Okay, origin should move here, and this maximum point should moving here as well. This intercept point moving here. So later the principal axis would be here. Okay, the straight line. So this is 2 pi, 3 pi, 4 pi. Okay, so all coordinates point will moving. Okay, as far as 0.5, 2 downward. And after that, connecting all coordinate point. And if you connecting all coordinate point, okay, will be like this. Okay, the blue one. So this is the graph. This is the graph of y equals sine x minus 0.5. How to sketch this graph based on the main graph. Yeah, just translating 0.52 downwards. So we could say that graph y equals sine x translated vertically two downwards by 0.5 units. Okay, and the graph is one. This is the graph of y equals sine x minus 0.5. Okay. Okay, around until around here. Okay. Graph of y equals sine x minus 0.5. Now we are going to sketch y equals sine x minus 2 based on this main graph y equals sine x. Okay. Uh, X minus 2, it means uh, we can we can determine this graph based on translations of this graph y equals sine x. And this translation type is a horizontal translation. Okay, it's horizontally translation to the right. Because minus 2 is plus, if plus 2, it means the translation to the left. Okay, translation to the right, it means all coordinates point on this graph, y equals sine x, moving 2 units to the right. So we could say that graph y equals sine x, okay, translating horizontal, okay, translating horizontally to the right by 2 units. Okay, so uh, this origin, this coordinate point, moving 2 units, 1, 2, moving here as well. This maximum point moving 2 units, 1, 2, moving here. Okay, and then this is inner point pi should moving uh 2 units, 1, 2, moving here. Okay, then as well this maximum point moving 1, 2 around here. Okay, okay, but probably some of you ask me, sir, uh what is the new coordinate point here, and the minimum point as well when it moves. Okay, 1, 2 around here. What is the coordinate point here? Okay, uh, because if the graph like this, that's simple for you to create the new graph, but how if the x-axis not on integer but in pi? Okay, but to make you easier, firstly you have to create your graph, in x-axis in integer. Okay, the unit in integer 1, 2, 3, 4, 5, 6, and so on. Of course, pi equals 3.14. Okay, and then to pi, of course, 6.28, so on until here 4 pi, okay, 12 point blah blah blah, right? But if you want to, if you would like to find first this one, the inner point 1, 2, uh, what else? This move around here, okay, 1, 3, and this will move around here, okay. So how you determine this coordinate point 1, 2, 3, 4? Okay, as well the maximum point is 1, 2, okay, 3. Okay, this is the maximum point, and as well this will move. This minimum point will moving around here. Oh, no, it's only this one. Okay, this I'm going to show you. Firstly, we need to find the x-axis intercept. X-intercept, it means y equals 0. Okay. If y equals 0, it means the equations become sine x minus 2 equals 0. Right. Okay. Then wait, I'm going to scroll down first, right? And we have to convert this integer becomes decimal, becomes degrees, and after that becomes pi. Okay. Convert into pi because this x-axis unit in pi. So it's going to be sine, okay, x minus 2 times 180 over pi. Okay, it's going to be sine x minus, okay, calculate, wait, yep, it's 114.65. Okay. And after that, we have to convert this into pi. Okay. So, okay, becomes sine x minus, wait, I'm going to find first letter. Okay, it means sine. Okay, it means no x minus 114.65 equals 0 because this is equals sine 0. Okay, so x1 equals 114.65, or in pi conversion 0.64 pi. So this coordinate point, okay, is 0.64 pi, comma 0 because y equals 0. So what this one? This one. Just simple, just add pi. So x2, wait, I'm going to using this space. Okay, I'm gonna writing here, move here. Okay, so it means x2 equals 0.64 pi plus pi 1.64 pi. This one. Okay, so this coordinate point is 1.64 pi, comma 0. Okay. Then x3, 1.64 pi plus pi is going to be 2.64 pi. It's one, it's one. Yeah. It is 2.64 pi, comma 0. Okay. And x4 is this one, 2.64 pi plus pi equals 3.64 pi. this point. Okay. And after that, we are going to determine the maximum and minimum point. But I'm going to show you if we connecting all our coordinate point. Okay. Now from it's gonna move here, so we can create the new graph. Okay. I'm going to using blue color. If we sketch the graph, it's gonna be like this. Okay. Okay, like that. And let's we look at the precise graph. Okay, I have created this one. Yeah. Now the question is, some of you may be asking me, so how about the maximum point just now? We already concerned into this intercept point with x-axis. Okay, already determined one. Okay, this is already we already determined this. Now we are going to determine this maximum. Okay, minimum and minimum here, and as well here this minimum, and uh intercept with y-axis. Okay, intercept with y-axis. I'm going to writing on this space. Okay, y-intercept. It means x should be 0. If x equals 0, that equation becomes y equals sine 0 minus 114.65 degrees. Okay, and if we calculate this sine negative 114.65 on calculator, we could find that this is negative 0.9. Okay, so it means, okay, this is scalar point, 0, comma, negative 0.9. Okay, now we are going to find this. Okay, the maximum point. Maximum point meaning if uh, if y equals 1. If y equals 1, how much x? Okay, okay, we are going to determine this. Okay, as well this. Yeah. Okay. I'm gonna move into this space. Okay. If y equals 1, okay, if y equals 1, so the equation becomes sine x minus 114.65, okay, equals sine 90, because sine 90 is 1. Okay. So it means sine, x minus 114.65 plus 90. X equals 114.65 plus 90. Okay, so it's going to be 204.65. Okay, degrees. So we are going to convert into pi times pi over 180. So it will be the x1, it will be 1.14 pi. So what x2? X2 gonna be 1.14 pi plus 2 pi. Okay, it's going to be 3.14 pi. So the coordinate point, okay, 1.14 pi, comma 1. And this one, the second coordinate point, 3.14 pi, comma 1. Okay, I'm going to show you the maximum point. Okay, so this maximum point, the coordinate point of this maximum point is 1.14 pi, comma 1, and this one 3.14 pi, comma 1. Okay, now I'm going to show you how we find the minimum point. So 1, 2. Okay, I'm going to move into the space. Okay, so if it means y equals -1. If y equals -1, it means the equation becomes sine x minus 114.65 equals sine -90. And it's going to be x minus 114.65 equals -90. Okay, so it means x equals 114.65 minus 90, and it is 24.65 degrees, or if you convert into pi, it's going to be 0.14 pi. So the coordinate point 0.14 pi, comma, -1. This is the coordinate point 0.14 pi, comma, -1. Now we are going to find this. That is x1, x2, x2 equals 0.14 pi, okay, plus 2 pi, okay, and it's going to be 2.14 pi, and the coordinate point 2.14 pi, comma, -1. This the coordinate point 2.14 pi, comma, -1. And I'm going to show you the graph. This is the graph. This is the graph. If we're connecting all coordinate point, this is the graph. Graph of y equals sine x minus 2. Okay, let's move to this graph, sine x plus 2. Okay, we are going to sketch this graph based on the main graph. One, the main graph is y equals sine x. Okay, yeah, this is if x unit in integer, but I'm going to remind you that the intercept with x is pi, 2 pi, 3 pi, and 4 pi here, right? Now, based on this question, y equals sine x plus 2, it means the translation, horizontally translation, but the direction to the left. If minus to the right, and if plus to the left. So we could say that graph y equals sine x uh, translating horizontally uh, to the left by 2 units. Okay. So this graph y equals sine x will be all coordinate point will be moved 2 units to the left. Okay, so I'm going to show you this coordinate point will be moved 2 units, one to around here. Okay, it's gonna move here. Then this maximum point as well will move one around here, but recall that the interval from 0 to 4 pi. So we are not going to drawing on this negative side, right? And then, yeah, move here. So we are going to find the intercept point with y. After that, then this coordinate point will moving here. Okay, this coordinate point will moving here. Okay, and this coordinate point will moving here, around here. Okay, now we are going to find the intercept point with x-axis, of course, in pi. Okay, and as well, the intercept point on y-axis. I'm going to move here. Okay, x-intercept it means y equals 0. Okay, if y equals 0, the equation becomes sine x plus 2 equals 0. Okay, so we are going to convert to, like just now, x plus 114.65. Just now, we already calculate this. Okay, sine 0 So x equals negative 114.65. So it becomes with our negative, yeah, 0.64 pi. But we are not going to using this because the position on the negative side. But we will start from this x1, negative 0.64 pi plus pi. So it means 1 minus 64. It's going to be 0.36 pi. X2, it means plus, oh yeah, plus this one, plus pi, 1.36 pi x3, 1.36 pi plus pi, 2.36 pi x4, 2.36 pi plus pi, 3.36 pi. Okay, so the coordinate point R, this is 0.36 pi, comma 0, 1.36 pi, comma 0, 2.36 pi, comma 0, and 3.36 pi, comma 0. Now, let's define those coordinate points. The intercept point with x, with x-axis, it means this one first. This is 1.36 pi, okay, and this one, secondly, 2.36 pi, and after that, this one, 3 point, yeah, 3 point, sorry, not this one, sorry, this is 0, supposed to be the 0, after that, 2, after that, yeah, 0, 1, 2, and 3, okay, forgot, 0 first, so that's 1.26 and 2.26, and then 3 point, this one, 3.36 pi. Now, let's find this maximum. Sorry, this one first. Intercept point with y. Okay. Next, y-intercept. With y-intercept, y-intercept, x should be 0. If x equals 0, it means the equation becomes sine 0 plus 114.65. Okay. So y equals sine 114.65. Okay. Let's calculate calculator. Okay, it is 0.9. Okay. So it means the intercept point here 0.9. Okay. 0.9. This one here. This is the intercept point. 0, 0.9. Okay. Now, I'm going to show you how we find this maximum point, the coordinate point. Okay. Okay. Maximum point, it means if y equals 1. If y equals 1, it means the equation becomes sine x plus 114.65 equals 1 or equals sine 90. Okay, because sine 90 equals 1. So it means x plus 114 plus 65 equals 90. So x equals 90 minus 114.65. Okay, let's recalculate. It is negative 24.65. After that, convert into pi. It is negative 0.14 pi. Yeah. Okay. But this on the left side, on the negative side. So I'm going to start with x1 here. x1 equals negative 0.14 pi plus pi. Okay. So it means minus. It's gonna be, wait, 1 point, okay, sorry, should be 2. Okay, plus 2 here because maximum. Okay, the distance 2 pi. Okay, between this maximum and this maximum point. So it will be 1.86 pi. And so the coordinate point 1.86 pi, comma 1. Yeah. So if it move, or if this move, it's gonna be this one. Yeah. Move 2 steps to the left. And then x2 1.86 pi plus 2 pi equals 3.86 pi. Okay. So the first coordinate point 1.86 pi, comma 0, comma 1, sorry, comma 1 because maximum point. And this is 3.86 pi, comma 1. Okay. And okay, I have create a graph. You could see this, the graph. Okay, it's one. Okay. And if you will sketch this graph, okay, don't forget this is the intercept point with y, okay, 0, 0.9. And this one already, we already find this one, okay, this one as well, okay. Already this one as well. I'm going to show you again the intercept point, this, okay, 0.36 pi, and this one 1.36 pi, 2.36 pi, and 3.36 pi. Okay. Okay. That's the initial point with x. Now the maximum point, just now we already calculate this maximum point, this, okay. The maximum point is 1.86 pi, comma 1. And secondly, this one, 3.86 pi, comma 1. So how about this the minimum, the minimum point here? How much? So supposed to be, you have to find all coordinates point, intersect with y, intersect with x, maximum point, minimum point, and after that, connecting all coordinate point. Okay. I'm going to show you how we find the minimum point, the coordinate point of minimum point. The minimum point happening on y equals -1. Okay. If y equals -1, okay, we can determine through this equation that sine x plus 2, okay, equals sine -90, because sine -90 equals -1. So the implications x plus 2, I will convert into degrees. Okay, -90. So x cos -114.65 minus 90. Okay, so it is negative, wait, okay, it's 204.65. Okay, or I'm going to convert into pi with calculator. Okay, it's 1.14 pi. But we are not using this number because the interval between 0 to 4 pi. Okay, it means x1 equals -1.14 pi plus 2 pi. Okay, it is 0.86 pi. So the coordinate point is 0.86 pi, comma -1, x2, okay, equals 0.86 pi plus 2 pi equals 2.86 pi, and the coordinate point 2.86 pi, comma -1. Okay, let me find the coordinate points. Okay, so this is the coordinate point. This is 0.86 pi, comma -1, and this coordinate point 2.86 pi, comma -1. Okay, so supposed to be you have to find all coordinate point, intercept with y, intercept with x, 1, 2, 3, 4. After that, minimum point, maximum point, and connecting all coordinate point, and you will find this graph. Okay, this is the graph of y equals sine x plus 2. Yeah. So again, you have to find all coordinate point first, and after that, connecting all coordinate point, then you could find the graph. Fy equals sine x minus pi over 4. We're going to sketch this graph based on the main graph y equals sine x. Okay, because y equals sine x minus pi over 4 is translation graph by this graph y equals sine x. Okay, and the translation is translation on horizontal. Okay, horizontally translation, and then uh yeah, as far as pi over 4. Okay, as far as pi over 4 to the right. Yeah, because negative, right? Now we're going to find the coordinate point of translations translated by this graph y equals sine x. Okay, uh, but I'm going to state that graph y equals sine x. Okay, translating horizontally. Sorry, horizontally. Okay, to the right. By pi over 4. Okay, it means this. I'm going to start with this. Yeah, this origin. Okay, origin should move to the right as far as pi over 4 or 45 degrees. Okay, uh, around here. Okay, so it means this is pi over 4 comma 0, and then translations of this coordinate point. Okay, pi over pi comma 0, it means pi plus pi over 4. It becomes 5 over 4 pi comma 0. Okay, and as well this is 2 pi if translated by sine x minus pi over 4. Okay, this coordinate point should be moved here, around here, and it means the translation becomes 5 over 4. 7 over 4. Okay, because 2 plus 1 over 4, 9. Sorry, not 7, 9 over 4, pi, comma 0. And as well, this is 3 pi. Okay, I'm going to move here, around here. And translation becomes 13. Yeah, 13 over 4 pi, comma 0, because 3 plus a quarter. And this point as well moves to the right side, but our interval just 0 until 4 pi. Okay, right. The maximum point, it means translating to the right side around here. Okay, pi over 4, it means if you would like to find the coordinate point, this is pi over 2, half pi. It means this coordinate point is, wait, pi over 2 plus pi over 4. It's gonna be 2 over 4, yeah, 3. 3/4 pi. So it is 3/4 pi, comma 1, right? And so it means, yeah, this one plus 2, yeah, 3 plus 3/4 plus 2, it means 2 3/4 pi, comma 1, okay, or 19 over 4, comma 1. So about this, okay. This coordinate point is 3, yeah, 3/2 pi. That means 3/2 pi plus pi over 4. It's going to be 6 plus 1, 7. 7 plus 4 pi. So around here, okay. The coordinate point 7 plus 7 over 4 pi, comma negative 1. And this is 1. 7 over 4 pi plus 2 pi. Okay, it's going to be 3/4 pi. So the coordinate point 3/4 pi, comma negative 1. And after that, connecting, we have to calculate the intersect point with y-axis. I'm going to move to, I need more space. Okay. Okay. If y-intercept, it means x should be 0. If x 0, the equation becomes y equals sine 0 minus pi over 4. It's going to be sine negative pi over 4, or negative sine pi over 45. Sorry, for 4, or sine negative 45. Okay, it means negative half square root 2. Okay, so the coordinate point 0, comma negative half over 2. Now we find the graph. Okay, okay, the sketch graph like this. Okay, look at the translation. Okay, the main graph y equals sine x translating to the right side horizontally by pi over 4, and this is the intercept point 0, negative half square root 2. And then this is just now we already calculate this is 3/4 pi, okay, comma 1, and this one 3/4 plus 2, 3/4 plus 2, 2 3/4 pi plus 3/4 3 2 3 over 4 pi, comma 1, or 11 11 pi comma 1. Okay, and this one, the intersection graph with this x-axis and the minimum point here. Okay, just now we calculate already is 7 over 4 pi comma negative 1, and this is, yeah, 7 over 4 plus 2, it means 15. Okay, 15 over 4 pi comma negative 1. Okay, yeah, this one, just now this is 13 pi, this is 3 4. Okay, and this one, this is just now pi over 4. Okay, this is 1 plus pi over 1 plus 1/4, so it means 5 over 4 pi this. Okay, it means this one 9 over 4 pi, the intersection. And finally, if you connecting all coordinates point, it's going to be like this. This is the graph of y equals sine x minus pi over 4. Now this one, y equals sine x minus pi over 6 plus 1. There are two translations. The first translation, okay, I'm going to writing here that there are two translations. Because we are if we will sketch the graph of this equation y equals sine x minus pi over 6 plus 1, we just create firstly the main graph y equals sine x. Okay, after that, uh, translating through uh, this graph. Wait. Okay. And the translation, firstly, horizontally translation. Okay, to the right, of course, and then pi over 6. And secondly, vertically translation, uh, two upwards by 1. Okay, by 1 unit, and yeah, 1 unit, and of course pi over 6 units. All right, and it means we have firstly we need to the first step we need to find these translations, x minus pi over 6, or translations minus pi over 6. It means the translation to the right side as far as pi over 6. This is pi over 2. Okay, the maximum, it means translations of pi over 2 is pi over 6 plus pi over 2 um, becomes 4 Wait, times 2 is 3 over 6, 3 plus 1, yeah, 4 over 6 pi. So the translation comes, yeah, around here to the right, okay, and the coordinate point pi over 6, 4 over 6 pi, comma 1, okay, then this is pi, and translated to the right side around here, so pi plus pi over 6, 7 over 6 pi, so let's move to 7 over 6 pi, okay, and as well this origin moves to the right side as far as uh, pi over 6, okay, and as well this minimum point moves, translating, I mean, moves, because translation, and then it is 3 over, yeah, 3 over 2 plus 1 6, 9 over 2, 9 or 10, yeah. So the coordinate point 10 over 6 pi comma negative 1. So it means this one, the translations of this minimum point is 10 over 6 plus 2. Okay, 10 over 6 plus 2, it means 22. 22 over 6 pi. Okay, it's 22 over 6 pi, comma negative 1. And you can find here, okay, 4 over 6 plus 2. Okay, 2, 4 over 6 pi, comma 1. Here, the coordinate point. Okay, and as well, you can find the intercept point, such as such as the previous graph when I explained. Okay, and let's look the translation, graph translations. Okay, this one. Okay, so this is pi over 6. Okay, just now we found already this point, this coordinate point. Okay, supposed to be just now you have to connecting all coordinate point. Okay, you have to connect all coordinate point at the right side of the main graph. Okay, and the outcomes this the graph, this one, the blue color, the blue graph. Okay, and of this is the graph of y equals sine x minus pi over 6. Okay, and after that, after sine x, after this translation, negative pi over 6, the next translation is plus 1. Plus 1, it means all coordinates point translating to upwards as far as 1 unit. So from this maximum point, this is you have to add, add 1, this 3 4 pi comma 1, translating to upwards, yeah, around here, becomes 3 4 pi comma, translating plus 1 comma 2. Okay, as well this. Okay, this translation 2 3/4 pi comma 1 becomes 2 3/4 pi comma 2. Okay, yeah, translating as far as 1 unit 2 upwards. Okay, all coordinates point here. Right, so as well this point moves to upwards at here, translating, I mean, and as well this coordinate point moves around here, and this coordinate point as well moves here, and you can determine the coordinate point. For example, like this one is just now over this 19. Yeah. Sorry, if this is 7/4, it means this is 7/4 pi comma 0. Okay. This one 15. Yeah, 15/4 pi comma 0. Okay. Translations at this minimum point. And finally, the graph would be like this. Yeah. Okay. Yeah, it's the translation graph. Okay, the translation graph plus 1. Translation uh from sine x minus pi over 6. Okay, if you're connecting all coordinate points, the graph gonna be like this. And this is the graph after translation. Translations to translation. So this is the graph y equals sine x minus pi over 6 plus 1. Okay, so translations horizontally to the right side as far as pi over 6. After that, translations vertically to upwards by 1 unit. Okay, I'm going to move to KH. Y equals sine x minus 1 minus 2. As well, there are two translations. The first translation, there are two translations. If you want to sketch this graph, of course, through this graph, based on this graph, the main graph, y equals sine x, through two translation. Okay, first, horizontally translation. Of course, to the right, by 1 unit. Okay, by 1 unit. And secondly, at vertically, yeah, vertically translation. Okay, vertically translation. Minus 2, it means to downwards. By 2 units. Okay. Right. Now, how are we doing this? If x unit in integers like this, very simple. Yeah, but I recall that the interval from 0 to 4 pi. So this is 1 pi, 2 pi, 3 pi, 4 pi. Okay. If x-axis in integer like this, very simple, just its origin move to the right side one unit, one step, moved here. As well, this maximum move translating here. Okay. And this one as well, pi translating here. And this minimum point translating here. And this one as well, make maximum translating here. All of them translating to the right side. Okay, and after that, translating to downwards by 2 units. 1, 2, here, translating here. Okay, and then this one, okay, this coordinates point translating to downwards as far as 2, 1, 2 on here. Okay, as well this move 1, 2, as well this coordinate point moving here. Okay, and this coordinate point as well. Okay, moving translating around here. This coordinate point as well. Okay, and this one translating around here. Sorry, this one. This coordinate point, I mean, around here. Okay. This one, no. Okay. This coordinate point, okay, because it's translating around here. So this maximum point here. Okay, and as well this intercept translating here, and then this one becomes around here. Okay, and then yeah, only that. So we are going to connecting all coordinate point, but we have to find first the intercept point with y-axis. It means y-intercept, x should be 0. Okay. And if we connecting, yeah, around like this, okay. But we have to find this. Okay, we have to find intercept on y-axis if x equal 0. So it's gonna be y equals, okay, I need more space. Y equals sine 0 minus uh, yeah, just minus 1 just now, but we have to convert becomes degrees. So it's gonna be 57.8.3, sorry. Okay, minus 2. So it is, if we calculate, negative 0.8 minus 2, negative 2.8. So this coordinate point, the intercept point, 0, negative 2.8. That, yeah. Right, I'm going to show you the first translation. The first translation, this is y equals sine x minus 1, the first translation, this. And after that, the second translation, the green one, or the green color, uh, look at the second translation, all coordinate point of this blue graph are translating the downwards as far as two two units. Okay, because negative 1 plus 2. Okay, and the graph is 1. Okay, just now we already determined that this is 0, negative 2.8. Okay, the inner point is now already, and this one as well, we already determined. Okay, the maximum point, minimum point, maximum point, and the second minimum point. Okay, for the coordinate point, we already determined from on this first. Okay, you may determine the coordinate point. Okay, you may determine like my previous explanation. Okay, firstly you have to convert into pi, find this maximum point, after that plus 2 pi, and you can gain this coordinate point, and as well the minimum point you have to convert to uh, degrees or pi, and after that plus 2 pi, you can gain this coordinate point, the second minimum point. Okay, on this y equals sine x plus 4 plus pi over 4 plus 2. So there are, if you would like to find this this graph, if you would like to sketch this graph uh, by this translation, the main graph translation, sine x translation. So there are two translations. Okay. Firstly, yeah, horizontally. Horizontally translation. Okay. Of course, to the left, because this is plus. If minus, the horizontally translations to the right side. Okay, to the left by pi over 4 units. And secondly, vertically translation. to upwards because plus by 2 units. Okay. Now we're going to find the first translation. The first translations uh, 0 translating to the right side, yeah, by 4 over pi. So it's gonna be if it's a half, it means 1/4, yeah, around here. Okay, and then this maximum point as well, we're translating it, yeah, around here. Okay, so if this is pi over 2 comma 1, okay, it's gonna be pi over 4 comma 1. Yeah, translations of from this coordinate point, right? And uh, pi as well, translating to the left side as far as 1 over 4 pi or here. Okay, and then that this makes this minimum point as well around here. Okay, and then this coordinate point, this intersection uh, around here, the translation maximum point around here to the left here, and uh, we can create, okay, the first translation around here, around like this. Okay, I'm going to show you the first translation. Okay, this the first translation. The blue color. Okay, the blue color is the first translation. Okay, translating to the left side from the main graph from y equals sine x. And I'm going to fix this first. Okay. Right. And then after that, uh, it's gonna move to uh, upwards, okay, as far as 2 units. So, for example, this, okay, uh, the translation, this one, so it's gonna be pi over 4, comma 3, okay, and this one, okay, gonna move, not translating to this, into this coordinate point, okay, so pi minus 1/4, so means 3, comma 2, okay, then this minimum point, okay, so moving here, okay, and then this one thing here, intercept moving one, moving 2, wait, so moving here, okay, and this coordinate point translation translating to here, okay, as well here, and finally this one on here. So we can create the new graph, sketch the new graph like this. Okay, I'm going to show you the precise one of this graph. This, okay, look at the red color. This is the graph of sine x. Meanwhile, this is sine x minus sine x plus pi over 4 plus 2. Yeah, after two translation. This, so after two translation, the graph becomes like this: y equals sine x plus pi over 4 plus 2. Okay, so how about this intercept point? Okay, we may calculate through, so I'm going to use this space. Wait, okay. Okay, y-intercept x equals 0. If x equals 0, it means this equation becomes y equals sine 0 plus 45 pi over 4 plus 2. It becomes sine 45 plus 2. It's going to be half square root 2 plus 2, 2.7. Okay, that's 2.7. So this intercept point is 0, 2.7. Yeah. So 0, 2.7. So now y equals 3 sine x. Okay. If 3 sine x from the main graph, the difference is the maximum point. This graph then has maximum point 3 times of the first graph. Okay, if sine x maximum point is 1, this graph has maximum point 3. Yeah, so this the maximum point, and as well the minimum point -3. Yeah. Maximum point becomes 3, minimum point as well 3. How about the intersection with x-axis? Still same, still here. Pi, 2 pi, 3 pi, and 4 pi. So if we sketch this graph, it becomes like this. Yeah. Okay. For the precise graph, I'm going to show you this one. This is the both graph, the origin graph and the second graph. Okay. Y equals sine x and y equals 3 sine x. This is the graph y equals 3 sine x. So now it's 1k. Y equals half sine x. Similar with L, but this is half. It means from 1, yeah, the maximum point from 1 becomes half here. Okay, the intersection point C, minimum point from -1 becomes negative half. Okay, maximum point as well becomes half. The minimum point same. So if you scatter this graph like this, becomes like this. They have same intersection point. Wait. Okay, this is just sample. Okay, okay. And the precise graph, I'm gonna show you this, the both graph, sine x and half sine x. The blue graph is graph for y equals half sine x, and this one is the graph for half sine x. Now, y equals 3 half sine x. The procedure to sketch this graph, same with my previous explanation, that the maximum point from 1 becomes 1.5. Okay. The minimum point from -1 becomes -1.5. Then we can sketch this graph like this. Yeah. Okay. And the precise graph is the both graph. The blue graph is graph of y equals 3 half sin x. The red graph is graph of y equals sin x. And this is the graph of y equals 3 half sine x. Okay. Next. And y equals sine 3x. We have to identify that amplitude equals 1. So it means the maximum point and the minimum point is still the same, 1 and -1. And then after that, this graph has horizontally stretched. Okay. I'm gonna writing here, horizontally stretched. By scale factor 1/3. Scale factor 1/3 and has period. Okay, this is 2 pi, 4 pi, and the period is based on this equation that period 2 pi third. 2 pi third, it means one period consists of 3 waves. Okay, later we are going to divide one period becomes 3 waves. Okay. I'm going to divide. Okay. Divide becomes 3 part. 1, 2, okay, around here, okay, divide it. And then for this one, uh, yep, around here, right? So how about the maximum point and the minimum point? The maximum point would be stretched, okay, would be stretched one third. So from this maximum point, this coordinate point would be stretched to the left, becomes divided by 3 and one third around here. Okay, so it means this one as well, this minimum point would be stretched, okay, becomes here, okay, and then it will be here as well because we will sketch becomes okay, becomes two periods, okay, two periods on yeah, one period, I mean, or 2 pi, 3 waves. Okay, here, okay, ready, and then the minimum point here. Okay, after that, connecting all coordinates point from the origin. Okay, three periods. One, sorry, one period, two periods, the third periods. Okay, one, two, three. And as well, this for this period, 2 pi until 4 pi, we create 3 periods more. Okay, the maximum here and the minimum. We divide first becomes 3 parts. After that, find the minimum and the maximum. Of course, the minimum between this, for example, on this wave, the maximum between those coordinate point and as well the minimum point. But they still have same intersection with the main graph. Okay, I'll continue. One, okay, two, three. Okay, let's we look the precise graph I have provided. That's the blue graph is the graph of y equals sine 3x. Pi here, 2 pi, and then this is 3 pi, 4 pi here. Okay, the interval from 0 to 4 pi. And I have created this is the graph without without the main graph. Okay, 0, okay, pi, 2 pi, Okay, this is 4 pi. Okay, so yeah, 3 pi here. Okay, right. And wait, pi here, right? And y equals sine half x. To sketch this graph, the information we have to we need that this this graph has horizontally stretched. Okay, okay. It has horizontally stretched by scale factor 2. So 1 over half. 1 over half equals 2. So how about the periods? Periods, it has period 2 pi over half equals 4 pi. Yeah, the period. Right. What's for this? This information useful for us to create this graph. Okay. If scale factor 2, it means uh, 2, 1 period, I mean 1 period, 0 to pi consists of half waves. Okay. Or uh, 0 to 4 pi, or 2 periods consist of uh, consists of 1 waves. Okay, yeah. So that's meaning of stretched by 2. So we can create the sketch of this graph. We have to separate first. 1 period 0 to pi becomes 2 part. Okay, because scale factor 2. Okay, 1 period divided becomes 2. So of course here the middle, and the maximum point being here. Okay, this the if you divide it become from between this maximum point and here, the middle are around here. Okay, so after that you may create. Okay, and another one divided as well. This becomes 2 parts. It means the minimum point gonna move it here. Okay, like, like that. Let's we look the precise graph. This one, the blue one is the graph. Uh, graph of y equals sine x over 2. Okay, and this is the graph after uh yeah, after stretching. Okay, after transformations by horizontally stretch. Okay, pi here, this is 2 pi, uh, 3 pi around here, and 4 pi here. Okay. Oh, y equals sine 4x. Uh, as I tell you that we have to identify first that for graph y equals sine for x, okay, that it has horizontally stretched, okay, by scale factor 1/4, 1/4. So what period? Period, it has 2 pi/4. It means uh, 4 waves on one period, 0 to 2 pi. Okay. Scale factor 1/4, it means we will divide, becomes 4 part. Yeah. From 0 to pi divided by becomes 4. Okay. Becomes 4 around here. Okay. If 4 waves 0 to 2 pi, it means 0 to 4 pi becomes 8 waves. Okay. Let's we determine the maximum and minimum point. Okay, it will be here. Well, the maximum and minimum point is the same, 1 and -1. Okay, to create 1, 2, 3, 4. Okay, it means 1, actually this one here until here. 2, 3, 4. Okay, I have provided the precise graph. This one. You can see this one. Okay. 0, pi, 2 pi, 3 pi, 4 pi. And as well, the graph y equals sine 4x after horizontally stretched. Pi to pi here. Okay. Number 9, sketch the graph of the following for x greater than or equals -2 pi, less than or equals to pi. Okay, so the interval from -2 pi until 2 pi. Okay. 9ay equals cosine x plus 2. We are going to sketch this graph based on the main graph y equals cosine x. Okay. Through transformation, we are going to find this graph. We are going to sketch this graph. Okay. Of course, based on this question that we are going to sketch y equals cosine x plus 2, it means this graph, we can sketch through this graph y equals cosine x through horizontally, I mean vertically translation to upwards, because plus 2 cosine x plus 2. So it's cosine x plus 2. It means there is a translation to upwards by 2 units, because plus 2. So it means all coordinates point on this graph y equals cosine x should moving 2 steps or 2 units to upwards. For example, this maximum point moving to here, to unit 1, 2, to unit moving here. Okay, I'm going to use blue color. Okay, here, and after that, this minimum point as well, translating here, this inner point translating as far as 2 units, and this coordinate point as well, moving here. Okay, and 2 pi moving around here. Okay, and this coordinate point moving here. Okay, all coordinate point on this this graph y equals cosine x, translating 2 upwards as far as 2 units. And after translation, this the graph. The blue graph is the graph after translations from the main graph. This is the main graph y equals cosine x. Okay, I forgot to writing here. This is pi here. Okay, 3.14 and 2 pi here. Okay, negative 2 pi here. And this is negative pi. So, and the graph y equals cosine x plus 2, this one. Okay. Of course, pi, okay, minus pi, and then minus 2 pi, okay, 0 here, okay, pi and 2 pi, okay. This is the graph y equals cosine x plus 2. We got this, we sketch this graph based on translations by graph cosine x. Now we are going to sketch this graph y equals cosine x minus pi over 4. Okay, and how to sketch this graph? We are going to using a method by transformation from this main graph y equals cosine x. Okay, y equals cosine x minus pi over 4. It means The types of transformation we are going to use is translation, horizontally translation uh, to the right. That's the direction. Again, horizontally translation. Okay, horizontally translation to the right as far as pi over 4. Okay, pi over 4 or 45 degrees. As you know that this is half pi, okay? This is pi, and this is 3 half pi, 2 pi, and this one is negative half pi, and this is negative pi, negative 3 half pi, and this is negative 2 pi. Okay. Now we are going to translating several coordinate point, okay, to the right as far as 45. If this one, from 0 to this coordinate point, uh, the distance 1 over 2 pi or half pi, so it means pi over 4 from here. So it means this coordinate point moving here, translating into here, and probably some of you asking me, sir, how about the coordinate point? So the coordinate point being pi over 4, comma 1. And you can determine all coordinate point based on this method. Just 0 plus pi over 4. And as well, this coordinate point moving here, translating into here, okay? It's going to be half plus quarter. It means 3, okay, 3/4 pi comma 0, okay. And as well, this one, you may determine this is pi comma negative 1, but the translation becomes here, okay, around here. And this is pi plus 1 over pi. It becomes 5/4 pi comma negative 1. And as well, this one, the translation here, and 2 pi, it's all cannot, because the interval just until 2 pi, and then what this maximum point, okay, the translation here, this intercept point, the translation around here, okay, and this minimum point as well around here, and this intercept point around here. So we can sketch the graph such as this one, okay. Okay, through our coordinate point, okay, around here. Okay, I'm going to show you the precise graph, this one, the blue graph. This is the graph after translations as far as pi over 4 from the main graph y equals cosine x. And this the final sketch. Okay, after we sketch, this is the graph. This is the graph of y equals cosine x minus pi over 4. Now we are going to sketch this graph. Y equals cosine x plus pi over 6. Okay. It means we will sketch the graph based on transformation. This translation to the left as far as pi over 6 or 30 degrees. Okay, so all coordinate point on this graph moving to the left as far as 30 degrees. Okay, this is negative half pi, negative pi here, minus 2 half, 3 half pi, and this is negative 2 pi. Half pi, 3 half pi, and 2 pi. Okay. Now, all coordinates point on this graph, y equals cosine x, should moving to the left as far as pi over 6 or 30 degrees. Okay. If this is pi over 2 or on 90 degrees until here, it means the divided becomes 3 parts. Okay. To find the 30, okay, around here, this is pi over 6. So it means the maximum point moving here and the coordinate point pi over 6, comma 1. Okay. And then as well, this coordinate point, this intercept point moving around here. Okay. So you can determine through negative, uh, negative pi over 2. Okay, wait. Negative pi over 2 minus pi over 6. Okay, times 3. Okay, negative 4. Okay, so this is minus 4 over 6 pi, comma 0. Okay, this if you want to determine the uh, translation. Okay, as well, this minimum point moving as far as 30 degrees or pi over 6. Okay, this coordinate point as well. Okay, and after that, this coordinate point as well, moving around here. This minimum point, it is inner point around here, and this maximum point. After that, we're going to sketch. Okay, it becomes okay. Wait. Okay, connecting all coordinate point. Okay. Okay, and the graph will be like this. I'm going to show you this one. The blue graph is the graph after translation as far as pi over 6. Okay, and I'm going to identify that a pi around here. Okay, negative pi. This is negative pi half. It's 1/3 pi. Okay, negative 2 pi. 2 pi, and then this is half pi, and this one 3/2 pi. 0 here. Okay. And if we sketch without the main graph, this one. So this is the graph of y equals cosine x plus pi/6. Okay. To make complete, this is pi, and then this is pi, negative 2 pi. 0 here. Okay. Let's continue. Now, y equals 3/2 cosine x. Okay, if 3/2 cosine x, implication to the maximum and minimum point. If cosine x has maximum and minimum 1 and -1, okay, so 3/2, it means the maximum point will be 1.5, because 3/2 equals 1.5, and the minimum point will be -1.5. Okay, here. Okay, so how about intersection point? Same, still here. Okay, okay. Now we are going to sketch this graph. Okay, around like this. Sorry, to 1.5. I mean, okay. Okay, I'm going to show you the precise graph. That's the blue graph. That is the graph after stretching. Yeah, stretching the graph y equals cosine x. Okay, and this one. Okay, that's one, the graph of y equals 3/2 cosine x. Negative cosine x. If negative cosine x, look the sign in front of cosine is negative. It means the type of transformation is reflection. So we are going to reflecting all coordinate point, okay, on y equals cosine x, okay, with reflector x-axis, okay, so x-axis is the reflector until we got this graph. We sketch that graph. So how to reflecting? So this maximum point, okay, will be the minimum point here. The minimum point gonna be the maximum point here. How about the inner point? Still same here. Okay, maximum becomes minimum. The minimum becomes maximum. Maximum becomes minimum. And after that, sketch that graph. Okay. Okay. That's one the graph. And the precise graph, I'm going to show you. This is the graph. The blue graph is the graph of negative cosine x. I'm going to add pi here, okay, to pi, okay, 0, negative pi, negative 2 pi. And this is the graph after reflection. It's the graph y equals negative cosine x. Okay. Pi, 2 pi, negative pi, negative 2 pi. Okay. Next is one, cosine x minus pi over 6 plus 1. So first we are going to find translations to x, translations pi over 6. So this translations is this translation is the horizontally translation, and the direction is to the right because negative pi over 6. And it means if you're translating this graph, it will be, I'm going to show you. Okay, pi over 6, it means 30 degrees. Just now, we already translated our graph. Okay, but this direction to right. So if this one is half pi or 90, okay, it means pi over 6, okay, around here. Okay, so translating to the right. After that, plus 1 after translation to right side by pi over 6 unit, and then continue to translation, vertically translation to upwards, because plus 1, it means the coordinate point after translation is 1. Yeah. all coordinate point on this graph, y equals cosine x, translating by pi over 6 to the right and by 1 to upwards. Okay, so what about this one? By pi over 6 to right, and after that 1 unit to upwards. It's fun. Now this in a set. By pi over 6 to right and 1 unit to upwards. This coordinate point as well. By pi over 6 to the right, after that 1 unit to upwards. This maximum as well. To the right, pi over 6, and to upwards 1 unit. This minimum point as well. To the right, pi over 6, and to upwards 1 unit. This one being this is moving here, okay? And this inner point moving here, okay? And this maximum point around here. Even this no need to continue until here, okay? Right. Let's sketch. Okay. That. Okay. Okay. So the precise graph, I'm going to show you this. Okay. After translation to the right side by pi over 6 and to upwards by 1. This is the translation. Okay. Pi. Negative pi is 0. And let we see the graph. This the graph after we sketch. Okay. So this is the graph y equals cosine x minus pi over 6 plus 1 after two transformation, two translation. Now this cosine x plus pi over 4 minus 1. So there are two translation here. Translation to the left side by pi over 4, and after that to downwards, yeah, by 1. So for example, this firstly to the left by pi over 4 or 45 degrees. Okay, if this is by half, okay, negative. 3 over 2. Okay. Okay. All right. Now we are going to find the translation after translation pi over 4. Okay, pi over 4. It means this coordinate point moving here. Okay. This coordinate point moving here. Okay, this minimum point as well going to moving here. Okay, and this intercept point as well here. Okay, so this one removing around here. Okay, and after that we can create the graph based on translation to pi over 4 to the left. I'm going to show you the first translation. There are two translations, but I'm going to show you this after translation to the left, okay? And then two downwards, okay? So look that after this translation, okay? Translation to the left. After that, 1 unit to 1 unit to downwards. I'm going to using this color blue, okay? In here, okay? Moving to downwards and run 1 unit as well. This is moving here, okay? It's gonna move in here because 1 unit to downwards, okay? Okay, and we may, okay, that is one by moving around here and then, okay, so it's gonna be like this, okay? So we start from negative 2 pi. Okay, and the precise graph, it will be like this, okay? The blue graph is graph after translation to pi over 4 and negative 1, okay? Pi over 4 to the left and 1 to downwards. So this is graph of y equals cosine x plus pi over 4 minus 1. Pi is 0 minus pi and minus 2 pi. Okay. This is the graph. Okay. Y equals cosine pi over 4 minus 1. Minus 1 cosine 2x. If cosine 2x, it means the transformations is stretch. Okay. So if one period consists of one period consists of one wave, okay, for this equation, if you want to sketch, one period consists of two waves because the stress by scale factor uh, by scale factor 1 over 2 half. So if half, it means one period consists of two waves. So uh, how we sketch this? Okay, firstly we create the maximum point, and there are two minimum point. Okay, around here. And we can sketch like this. Okay. Let's sketch like this. And then after that, oh, sorry, until here. Okay. Okay. It means here. And then I continue to sketch. And then here. Okay. Okay. And sketch like this. Okay. Okay. Half of the main distance. Okay. It's gonna be here. Okay. Like this. Okay. And I'm going to show you the graph. This one. After stretch. And this is the graph. This is the graph of y equals cosine to x. Okay, I'm going to complete with identify positions of pi to pi. Okay, as well here negative pi, and this is negative 2 pi. Next one, cosine x over 2. Cosine x over 2, it means this is stretched uh, by factor 1 over this stretch, okay, by scale factor 1 over half equals 2. If 2, it means the scale factor. If one period consists of one wave, okay, two periods consist of two waves, it means if the scale factor 2, two periods consist of one wave. Okay, and like this. Okay, the procedure like my previous explanation, like this. Okay, look that from minus 2 pi to 2 pi, there is one wave. Okay, okay, from negative 2 to here become is half wave and half wave from 0 to 2 pi. And this is the graph. I'm going to complete with the pi. This is pi. This is minus pi. This is minus 2 pi. Okay, 0 here. Okay, then sketch the curve y equals 4 sine x. For x interval 0 to 2 pi. After that, we're going to find x equals 5 pi over 6 and 7 pi over 4. Okay. Firstly, we have to sketch the graph, this graph, y equals sine x. Yeah, by this original graph, y equals sine x, okay, through transformations. Okay, if you look this equations y equal 4 sine x, it means it's gonna be have vertically translations or vertically stretched. I mean, vertically stretched, which is the maximum point will be moved uh, to here 4, okay, and minimum point as well will be moved here to -4. Meanwhile, initial point with x-axis still here, okay, and if you sketch, it will be like this, okay, and now we are going to find a solution through this graph. Y equals 4 sine x. Okay. Firstly, we are going to find the values of y. If x equals 5 pi over 6, okay. If x equals 5 pi over 6, okay, y how much? Okay. As you know that this is pi, it means 6 over 6. 6 over 6, and this is, it means 3 over 6 pi here, okay? And yeah, this is 4 over 6 pi, and then it is 5 over 6 pi, okay? And we can find, okay, y values here. Y equals 2, okay? And afterwards, 7 pi over 4, okay, or 7 over 4 pi. If x equals 7/4 pi, how much y? Okay. If 7/4, it means I'm going to separate this period. Okay. Becomes, yeah, becomes 4. Okay. I mean, if 1 pi, it means this is 4/4 pi. X over 4 pi. So 7 around here. I'm going to separate, divide becomes 2 parts. After that, yeah, 7 around here. So 4, 5 over 4 pi, 6 over 4 pi, 7 over 4 pi. Okay. If 7 over 4 position here, it means we can determine, okay, y around here. So if you create on millimeter block, you could find that y equals -2 or -2.8, yeah, or yeah, -2.8 or -2 square root 2. Okay, that's pi values. Okay, next. For what values of d does the graph of y equals 3 cosine x plus d lie entirely above the x-axis? Right. If entirely above the x-axis, all coordinate point, uh, all coordinate points should be greater than 0. Okay, greater than because of the position 0 position here, and you look that the negative the minimum point position here is -3. Okay, so it means all coordinates point of this graph, okay, should be greater than 0. And this graph is graph of, okay, I'm gonna copy this equation first, okay, and then scroll down. I'm gonna using this space, okay. It means all values should be greater than 0. It means y should be greater than 0. So 3 cosine x plus d should be greater than 0. Okay, because above of x-axis. So as you know that this is -3, so it means 3 times cosine. The value is cos -1, so it is -3 plus d greater than 0. So d should be greater than 3. Okay, because so -3 move to the right. B, how about if below of x-axis? If below of x-axis, it means as you know that the maximum point is 3. Okay, this one. So below of x-axis, so it means 3 cosine x plus d should be less than 0. Okay, it means 3 times, the maximum is 3. Okay, so 3 plus d less than 0. So d less than minus 3. Okay. And then C, the question partially above and partially below of the x-axis are. It means uh, d should be greater than -3 and then less than 3. Okay, combination of A and B. All right. 12. State the transformations which map y equals sine x onto y equals 2 sine 3x. Okay. So we are going to write down the types of transformation. As you know that on my previous explanation that I have explained regarding how we find the new graph as the outcomes of transformations of sine x and cosine x as well. Okay. In this case, so of course, there are 2 steps. Okay. Firstly, horizontally stretch, okay, by scale factor 1/3 because this is 1/3. Okay. by scale factor 1/3. And the second transformation is, yeah, vertically stretched because uh, there are integer in front of sine 3x. Okay, vertically stretched. Okay, by scale factor 2. Okay, so the maximum point increasing becomes uh, 2, and then the minimum point would be will be go down becomes -2. Okay, b this one cosine x onto negative cosine x. So if negative, it means there is a reflection, a transformation here. Okay, but the first step is this one. Okay, vertically stretched by scale factor 2. Okay, like this. Vertically stretched by scale factor 2, and after that, secondly, reflection. Okay, reflection in the x-axis. So the x-axis is the reflector. Okay, okay. See? Okay, see as well two types of transformation happening. Okay, sine x onto 3 sine x minus 5. Okay, firstly, because of 3 in front of sine x, so they are vertically stretched. Okay, vertically stretched by scale factor 3, and secondly, horizontally. Okay, it's -5. Oh, sorry, not horizontal. Vertically translation. Okay, vertically translation. Okay, vertical translation by 5. Okay, to downwards. Okay, because -5. Okay, okay, scroll down. Okay, and then that's one D. Okay, D, 2 again. Okay, firstly, cosine x plus pi over 6. It means uh, horizontally, yeah, this is horizontally translation. Okay, horizontally translation. Okay, uh, by pi over 6. Okay, to the left. Yeah, to the left side. So that's translation. And secondly, horizontally stretched. Okay, by scale factor. Okay, by scale factor. Uh, this one over 2.5. Okay. Then next. The thin sketch the graphs of the following x interval from negative 2 pi to 2 pi. Firstly, y over y equals negative sine x. Okay, negative sine x, it means there are two transformations here to find the new graph. Okay, firstly, we have to create becomes the maximum point becomes 3 and the minimum point becomes negative 3. Okay, this is vertically stretched. Okay, so it means the becomes 1 and minimum. Okay, while the intercept point is still here. Okay, and minimum point gonna be here. Okay, maximum point gonna be here. Okay, and if you sketch this graph, okay, firstly y equals 3 sine x. It's gonna be like this. Okay. Okay. I'm going to show you the precise graph. Okay, it's one the blue graph is the graph of y equals sine 3 sine x. Y equals 3 sine x. Okay. Look that this is the original graph y equals sine x. Okay. Becomes y equals 3 sine x. And next, we are going to continue to find the graph becomes y equals negative 3 sine x. If negative 3 sine x, it means reflection. Okay, we have to reflecting this graph. Okay, y equals 3 sine x. Okay, this maximum reflection becomes here. Okay, and this minimum reflection becomes here, and as you know that x-axis is the reflector. Okay, this is the intercept point. Okay, intercept point still here. Okay, and as well this one. This is the reflection of this maximum, reflection of this minimum here. Okay, and if you draw connecting all coordinates point. Okay. Okay, around like this. After this, I'm going to show you the precise graph. Okay, so on. Okay, look, this is the precise graph. Okay, uh, the red, the red graph is graph of y equals 3 sine x, and this one the graph. This is the graph uh, negative 3 sine x. So there are two transformations. Firstly, uh, firstly is vertically stretched by scale factor 3, and then secondly, the reflection on x-axis. Okay, next. B, y cosine to x plus 1. Okay, uh, to sketch this graph, y equals cosine to x plus 1, from this main graph, y equals cosine x, uh, we have to sketch based on two transformation. Okay, so firstly, I will show you that the first transformation is vertically, uh, the vertically, horizontally stretched. I mean, horizontally stretched. Okay, by scale factor half, and after that, vertically translation by 1 unit to upwards because plus 1. Okay, if uh, horizontally stretched by scale factor half, it means one period from negative 2 pi to 0. There are two waves, okay, and as well to uh, 0 to 2 pi, there are two waves, okay. And so how about the maximum and the minimum point? Okay, the maximums and minimum still same. Okay, with this main graph. Okay, and then the intersect point still same. Okay, I'm going to show you uh this one. Okay, look that this is I uh, already zoomed this graph. Okay, and you could see that in one period from negative 2 pi to 0, there are two waves, one, two. Okay, so the scale factor half, and 0 to 2 pi, there are two waves as well. Okay, so two periods consist of four waves. Okay, that is vertically stretched if the scale factor, uh, yeah, that's the, sorry, horizontally stretched if the scale factor half. Okay, and second step, as you know that this graph we will sketch is y equals cosine to x plus 1. Okay, this is the graph of cosine to x, the blue graph. Plus 1, it means all coordinate point on this graph, cosine to x, okay, should moving 1 unit to upwards. Okay, so this is a vertically translation. So this maximum point is moving here. Okay, okay, all coordinate point moving upwards by 1 unit. Okay, as well here. Okay. Okay, and if if you sketch, okay, like this, and I have provide the graph, okay, that's the green graph. The green graph is the graph of y equals cosine to x plus 1 after translations. Okay, so there are two transformations. Firstly, is horizontally stretched, and secondly, vertically translation. And this is the graph. Okay, I'm going to show you. This is the graph. Okay, the graph of y equals uh, graph y equals cosine to x plus 1. This one is the graph. Okay, and the interval is 2 pi, 0, and negative 2 pi here. Now this one, see, y equals half sine x plus pi over 6 minus 1/3. Okay, to sketch this graph based on the main graph y equals sine x, it means there are three types of transformation. Firstly, is horizontally translation. Uh, Horizontally translations pi over 6, it means to the left, okay, by pi over 6 units. So all coordinate point on this graph should moving to the left by pi over 6 units, or 30 degrees. Okay, because 180 over 6 equals to 30. So it means, for example, this origin, okay, if this is uh, pi, and then this is 90, it means, okay, 180, 90 divided by 3, around here. So it will be moving around here, okay? And as well, this maximum point will moving around here, okay? As well, this is pi will moving here, okay? All coordinate points should be moving to the left, okay? Okay? The coordinate point moving, and after that, you may sketch, okay? If you sketch, it will be like this, okay? The sketch, and I'm going to show you below. I have sketch, okay? Look that the blue graph is the graph of y equals sine x plus pi over 6, okay? The first transformation. So the first transformation is uh, the horizontally translation and the direction to the left by pi over 6 unit. After that, secondly, the second transformation is vertically stretched by scale factor half. Okay. Uh, okay. Look the well, okay. This is the scale factor. Okay, by the scale factor half. Okay. This it will be implicated to implication to the maximum and minimum point. Okay, so the maximum point will become half, okay, this just now. Look that in this graph, the maximum point is 1, okay, and minimum point equals -1, okay. Look the blue graph, okay, okay. Maximum point 1 and minimum point -1. So if scale factor half, it means implication to the maximum point and minimum point. Okay. If the maximum point 1 becomes half, okay, the minimum point -1 becomes negative half, okay, and this one as well, okay, this one, okay. Now that you sketch this graph like this, while the intercept point is still here, okay, and this is the graph. This is the graph of y equals half, okay. Sine x plus pi over 6, yeah, this one, yeah, okay, yeah. And next, after that, based on the equation that uh, finally minus 1/3. Minus 1/3, it means uh, the last step is vertically translation. Vertically translation to by the vertically translation by 1/3 units. Okay, minus, it means 2 downwards. Okay, I'll show you this. This graph, the green graph. Okay, the green graph is a graph of y equals half sine x plus pi over 6. Okay, should be moving 2 downwards as far as 1/3. Okay, okay, 1/3. It means, for example, this minus pi. Okay, it should be moving 1/3. Yeah, around here. Okay, it's 1/3 to downwards, and I have sketch. Okay, fun. The red. Okay, the red graph. Look that all coordinate point on this green graph moving to downwards. Okay, by 1/3. Okay, 1/3, 0.33. Yeah, around that 0.3. Okay, so this is the graph we will sketch based on the main graph. Okay, and I have create that graph. Okay, ready. This one. So this is the graph. This one. Y equals half sine x plus pi over 6 minus 1/3. Okay. Now D. Y equals 1/3 cosine x plus pi over 4 plus 1. Okay. To sketch this graph, based on the main graph, y equals cosine x, okay, there are 3 transformations as well. Okay. Firstly, horizontal translation. Horizontal translation, because we'll sketch this graph first. We are going to sketch cosine x plus pi over 4. Plus pi over 4, it means the translation to the left by pi over 4 unit. Okay, pi over 4 unit, it means 45 degrees. Okay, if this is negative um, by half, okay, it means half of this is 90, yeah, around here. Okay, so this meaning the maximum point should be moving here. Okay, and this inner point should be moving around here. Okay, and this is moving around here. So all coordinate point of this graph should be moving to the left as far as pi over 4 or 45 degrees. I have created the graph, okay, the blue graph. Look that all coordinate point on this graph, y equals cosine x, moving, okay, to the left by uh, pi over 4. So this graph is the graph of this cosine x plus pi over 4. Okay. Secondly, this is the first transformation. The second transformation is vertically stretched by scale factor 1/3. Okay. I'd like to show you again. Okay, this, look, the uh, transformation, okay, the stretch, vertically stretched, one third, okay. It means the maximum and minimum point uh, will be changed, okay, okay, one third, comes like this, okay. The green graph, okay, look at the maximum point and minimum point from the minimum point from negative 1 becomes negative one third, okay, and as well this one from negative 1 becomes negative one third, from 1 becomes one third, okay, as well this maximum becomes one third, okay, and I'm going to write down here 2 pi, okay, pi around here, pi, and this is, yeah, negative 2 pi, okay. That is y equals one third cosine x plus pi over 4. And next, this is the third transformation, that plus 1. It means, look, I'm going to show you the previous graph, okay. Plus 1, it means all coordinate point of this graph, y equals one third cosine x plus pi over 4, should moving to upwards by 1 unit, okay, because the third transformation is, wait, vertically translation, okay. Vertical translation, it means all coordinates point on this graph should moving uh, 1 unit, moving 1 unit to upwards, okay. So the red graph is graph after translation to upwards from this green graph. So this is the graph of this one, y equals one third cosine x plus pi over 4 plus 1. Okay, and I have sketched the graph. This is the graph. Okay, the graph 1/3 cosine x plus pi over 4 plus 1. Okay, so pi here, pi around here. Okay, minus pi and minus 2 pi. Okay, 0 here. Okay. Next one, we are going to sketch this graph based on the main graph. The main graph is sine x. How to sketch this graph? Okay, I'm going to show you sketch this graph through tree transformation. Okay, by tree transformation, we are going to find this graph. Okay, transformation from this main graph, y equals sine x. Okay, firstly, horizontally translation. Okay, because of this x minus pi third. Horizontally translations to the right side, okay, by pi over 3 units. Pi over 3, it means 60, okay. So all coordinates point on this graph, y equals n x, should be moving to right side by 60 degrees. If this is half pi, okay, half pi, it means 90, okay, if 90, it means this origin moving, yeah, around here, okay, because 60 degrees, 60 degrees to the right, to right side. So this one as well, so moving to, yeah, around here, okay, and this one as well, this coordinate point moving around here, okay, and yeah, this maximum point as well, moving around here, okay. So all coordinates point, and after that, yeah, connecting all coordinates point, okay, I have provided the graph. So the blue graph is the graph after translation, okay, after horizontal translation. Horizontal translation to the right as far as pi over 3. Okay, and this graph is a graph of sine x minus pi third. Okay, and the second step is vertically stretched by scale factor 3, because I'm going to show you the equation, this one. Okay, scale factor 3. Okay, the scale factor 3, so implicated to the maximum and minimum point. Okay, so it means this blue graph, maximum point and minimum point will be increasing. Okay, so this wave, okay, will be, the maximum will become 3 and negative 3. Okay, you look in the graph. Okay, one. The green graph is the graph of y equals 3 sine x minus pi third. So look that from 1 becomes 3, and as well as 1. From -1 becomes -3. This because of vertically stretched. Okay, vertically stretched by scale factor 3. So from 1 becomes 3. Meanwhile, the intercept point is still here. So this is negative 2 pi and pi around negative pi around here, pi here, and this is 2 pi 0 here. And the third translation, the third transformation, the third transformation is vertically translation to downward by 1 unit, because you have to look the equation. Look the equation. Yeah, -1. Okay, look, -1. It means a vertically translation to downward. Okay. Now, this graph, the green graph, will be moving. All coordinates point will be moving 1 unit to downward. Okay, and becomes the red graph. Look, the red graph already moving uh, as far as 1 unit. Okay, it's 1 unit moving. Okay, all coordinates point, and this is the graph of 3 sine x minus pi over 3 minus 1. And I have created the graph, this one. Okay, and this is negative 2 pi, negative pi from here, pi, and this is 2 pi, 0 here. Okay, that's the graph of y equals 3 sine x minus pi third minus 1. F y equals negative cosine half x minus pi 4. Okay, there are three transformation. Okay, firstly, horizontally translation to the right, because x minus uh, pi over 4. So I'm going to show you that we will sketch first a graph y equals cosine x minus pi 4. This graph. Yeah, if cosine x minus pi 4, it means horizontally translation to the right side as far as pi over 4, 45 degrees. Okay. So all coordinate point on this main graph, y equals cosine x, should be moving to the right side by 45 degrees. Okay, or pi of 4. If this is pi, this one half pi, it means pi over 4 around here. So this origin should be moving here. Okay, and this one should be moving around here. Okay, this maximum point moving here. Okay, it's moving around here. Okay, so all coordinates point of this graph are moving to the right side. I have created the graph. Okay, the blue graph. Okay, okay, the blue graph is the graph after horizontally translations as far as pi over 4 to the right side. And the second step is horizontally stretched by scale vector 1 over half. Okay, I'm going to show you the equation first. Okay, one. Look that cosine half. It means horizontally stretched. Horizontally stretched by scale factor 2 because 1 over half. Then it's gonna be, yeah, like if scale factor 2 on horizontally stretched, it means one period one period consists of half waves and two periods consist of one waves. Okay, so look the green graph. Okay, this is minus 2 pi and this is pi, 2 pi, I mean, okay. One wave, okay, from negative 2 pi to 2 pi. Okay, why? Because scale factor 2. Yeah, okay. If the difference, if scale factor half, it means one uh, one period consists of two waves. Okay, if scale factor 2, yeah, it means two periods consist of one wave. Okay, that's uh, that is horizontally stretched, different with vertically stretched. Okay, and I have created oh yeah, the last is reflection because uh, negative. Okay, if negative, it means the reflection of this. Look, that this is the graph of cosine half x minus pi over 4. And negative, it means the type of transformation is reflection. Reflection on x-axis. So x-axis is the reflector. So this, yeah, this point, this coordinate point becomes this coordinate point. Okay. So all coordinate point on uh, this graph, okay, reflecting on x-axis, and this is the red graph is the graph after reflection. Okay. And I have create the graph. This is the graph of y equals negative cosine half x minus pi over 4. Okay. Number 14, consider the general sine function y equals a sine b x minus c plus d. State which of the variables a, b, c, and d can be changed to always produce a change in a, the x-intercept of the function. Okay, so it means okay, 15, 14. Consider the general sine function y equals a sine b x minus c plus d. State which of the variables a, b, c, and d can be changed to always produce a change in okay, a, b, c, okay. This a effect has effect on amplitude, okay. This b has effect on horizontally stretched, and this C has effect on horizontally translation. And then this D, okay, has effect on vertically translation. So question A, the x-intercept of the function, uh, which one has effect? B, C, and D. Why? Because A just effect on amplitude, not in x-intercept. Okay. B, the y-intercept of the function, of course, D. Okay. Why D? Because y-intercept of the function also determined by maximum and minimum values. Minimum values. So that's why D has effect in y-intercept. See, the range of the function, of course, D. Why? Because range, as we know that range always in y-axis. Okay, so that's why D. Yeah, because D is vertically translation. That's one. Number 15, find the unknowns in each function. Okay. Firstly, this one, the function is fx equals, or I'm going to write down like this, okay, as a sine 2x plus d equals y. Okay. If the coordinate point pi over 12, comma 3, this equation becomes a sine 2 times pi over 12 plus d equals 3. So it becomes, I'm going to continue here, a times, okay, yeah, a sine pi over 6 or sine 30, okay. Sine 30 equals half. So this equation becomes half a plus d equals 3. And the second coordinate point, 3 pi over 4, comma negative 3. So this equation becomes a sine 2 times 3 pi 4 plus d equals 3. Okay. So it becomes a sine 6 over 4. 6 over 4 or 3 half. Okay. D equals 3. Okay. So sine 3 half equals negative 1 because this is 273. Okay. And with a negative 3. Okay. Now cancel D. Yeah, eliminated D. It becomes 3 half. 3 half A equals 6. So A equals 6 times 2/3. 4. Okay. Based on this equation, negative A plus D equals negative 3. So it is negative 4 plus D is negative 3. It means D equals 4 minus 3, 1. Yeah. So this is D and this is A. Let's continue. A cosine X plus D. Okay. A cosine X plus D equals Y. Okay. And the coordinate point pi third, comma 2 and pi, comma 5. Okay. Pi third, comma 2. This equation becomes A cosine pi third plus D equals 2. And yeah, cosine pi third is half 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 A plus D. And the second coordinate point, so A cosine pi plus D equal 5. Cosine pi equals negative 1. So this is negative 1. Okay. Minus, cancel D. 3 half A, negative 3. So A equals negative 3 times 2/3, negative 2. Okay. So negative A plus D equals 5. Okay. So negative of negative 2 plus D. D equals 5 minus 2. So D equals 3. Okay. C. A sine X minus pi over 6 plus D. Okay. And the coordinate point, okay. Just now this one, negative 2 and 3. Okay. C cosine of sine, I mean A sine X minus pi over 6 plus D. The first coordinate point is pi third, comma 3 half. So it is A sine pi third minus pi 6 plus D equals 3 half. This is A sine. This is times 2, 2 minus 1, or 1 over 6. So by 6 plus D, 3 half. And this one. And next is, let's check first. 5 pi over 6, comma 8 plus square root 3 over 6. Okay. Five pi over 6, comma 8 plus square root 3, comma 6. It becomes A sine 5 pi over 6 minus pi over 6. 8 plus square root 3 over 6. So it becomes A sine A sine 4. 4 pi over 6, or 2/3. Okay. Over 6. And after that, this equation becomes a sine pi over 6, or sine 30 is half of A plus D, 3 half, and then this one sine 2/3 pi. Yeah, square root 3 half. 6. Okay. Minus, cancel D. So it becomes half minus square root 3 half A. Okay. Equals 3 half minus 8 plus square root 3 6. Okay, I'm gonna move here. So becomes 1 minus square root 3 half A plus this is 9. 9 minus 8. 9 minus 8 minus square root 3 over 6. So simplify, 1 minus square root 3 over 2. A equals, this is 1 minus square root 3 over 6. So A equals 1 minus square root 3 over 6 times 2 over 1 minus square root 3. Okay, divided. Okay, equals 2 over 6, 1/3. Okay. I'm going to using this equation, half A plus D equals 3 half. A equals 1/3, so it means half times 1/3 plus d equals 3 half. So d equals 3 half minus 1 over 6 because it's 1 over 6. 9 over 6 minus 1 over 6, 8 over 6, 4 third. Okay, this is B, this is A. 16. Find the equation of its sine function. 16a, we are going to find these functions of this graph. Okay, if you look this graph, that this graph has amplitude 1 and then period 2 pi. So it means 2 pi over b equals 2 pi. So b equals 1, 2 pi over 2 pi. There is no horizontally translation. So the C of the value of C equals 0. Principal axis y equals -1 plus -3 over 2. -4 over 2 equals 2. So d equals 2. Yeah, -2. And the equation becomes y equals a sine from this form. Y equals a sine b x minus c plus d. So based on this information that y equals 1 sine 1x minus 0 minus 2. Okay, yeah. 16b, we identify first that amplitude equals 1. Amplitude equals 1. Period equals 2 pi. So 2 pi over b equals 2 pi. B equals 2 pi over 2 pi equals 1. There is a horizontal stretch. Okay. There is horizontally stretched by scale factor 1/3. Okay. And principal axis -1 plus 1 over 2 equals 0. So D equals 0. The equation y equals a sine b x minus c plus 2. So it's going to be 1 sine 1 over 1/3. 1 over 1/3. It means it becomes 3. Okay, so y equals sine 3x. See, I'm going to write down here in the space. See, amplitude equals 1, period is 2 pi. It means 2 pi over b equals 2 pi. So b equals 1. And this horizontally translation to the left. Okay. Horizontally translation to the left by half. Okay. Then primary, so principal axis, I mean. Principal axis 1 plus -1 over 2 cos 0 means D equals 0. This is C equals pi half. So the equation y equals 1 sine b, okay, 1 sine 1 times x, yeah, plus pi half, okay, plus 0, okay, this one is to the left, but it means if to the left negative, this one, okay. D. amplitude equal 3 minus negative 1, 3 minus negative 1 over 2 equals 2. Yeah. And period is 2 pi. It means 2 pi over b equals 2 pi. So b equals 1. 2 pi over 2 pi. And there is no horizontally translation. It means c equals 0, because without horizontally translation, the principal axis y equals 3 plus negative 1 over 2 is going to be 1, because 2 over 2. So d equals 1. And the equation y equals a sine b x minus c plus d. So y equals 2. Okay, 2 sine 1, okay, 1x sine x. It means because c equals 0, d, yeah, plus 1, because d equals 1. E, amplitude equals amplitude equals 3 minus negative 5. Okay, 3 minus negative 5 over 2. It's going to be 8 over 2 equals 4. Period is 4 pi. So 2 pi over b equals 4 pi. B equals 2 pi over 4 pi half. There is no horizontally translation, so it means c equals 0. The principal axis y equals 3 plus negative 5 over 2. It is negative 2 over 2, negative 1. So d equals negative 1. And the equation y equals a sine bx minus c plus d. It means y equals 4 sine, how much b? Half. Okay. Uh, half x, because c equals 0, half x minus 1, because d equals negative 1. F, okay, the period 6, the period is 6, yeah, 6 minus 6 minus negative 6. It means 6 plus 6 over 2. Period is 6. Uh, I mean, amplitude equals 6 and period equals 5. Now, yeah, okay, period equals 5. Okay. There is no horizontal translations. It means C equals 0 and principal axis Y. Okay. Let's define the equation. Amplitude equals 6 minus negative 6 over 2 equals 6. Period is 5. So 2 pi over b equals 5. B equals 2 pi fifth. Okay. There is no horizontal translation, so it means C equals 0. Principal axis. Y equals 6 plus negative 6 over 2 equals 0. It means D equals 0. And the equation Y equals A sine Bx minus C plus D. Y equals A how much? A 6 sine 2 pi fifth, okay, x here. 17. Okay, find the cosine function shown in this graph. 17a, amplitude is 2 because 2 minus negative 2 over 2 equals 2. Period is 2 pi. Okay. It means 2 pi over b equals 2 pi. So b equals 1. There is no horizontal translation, so it means C equals 0. There is a horizontally stretched. Okay. By scale factor half. Okay. And principal axis y equals 2 plus negative 2 over 2 equals 0. It means d equals 0. The equation y equals a cosine bx minus c plus d. It becomes y equals 2 cosine 1x. Okay, cosine 1, sorry, horizontally stretched 1 over half. It means 2. Okay. X minus 0 plus 0. Yeah, this one. Okay, to number 17b. Amplitude 3 minus 1 Okay. 3 minus 1 over 2 equals 1. Okay. Period is 4 pi. Okay, there is no horizontally translation. Okay, just horizontally stretch by scale factor 2. Okay, because 4 pi being 2 pi. Okay, right. Let's find the equation. Amplitude equals 3 minus 1 over 2, 2. Period is 4 pi. So 2 pi over b equals 4 pi. B equals 2 pi over 4 pi, equals half. There is no horizontal translations. It means C equals 0. Okay. Horizontally stretched by scale factor 2, then vertically translation. Okay. Okay, by scale factor 2. So D equals 2. And the equation y equals a cosine bx minus c plus d. Y equals 2 cosine, uh, cosine half. Okay, cosine half x minus 0 plus 2. See? Okay, C amplitude 5 minus negative 5. Okay, amplitude is 5, and there is no horizontally translation. It means C equals 0 and period, period, uh, yeah, 4 pi or period 2 pi over b cos 6, right? A equals 5 minus negative 5 over 2 equals 5. Period is 6. So 2 pi over b equals 6. B equals 2 pi over 6. Okay. Or pi third. There is no horizontal translation, so it means C equals 0. And there is a reflection, okay, on x-axis. Okay. Reflection on x-axis, it means x is the reflector. Okay. Principal axis y equals 5 plus negative 5 over 2 equals 0. So d equals 0. Reflection, it means we have to add negative. Okay. So the equation y equals a cosine b x minus c plus d. Y reflection, it means negative in front, negative 5 because a equals 5. Cosine b is 1 pi third. Okay, pi third x plus 0 minus 0 plus 0. Yeah, this one.